Hello guys and welcome to Left 4 Dead 2 running on 12K resolution, 10K resolution, 8K resolution, 5K resolution, 4K resolution, and 1080p resolution during our benchmark, during our test today on a laptop Asus GL702VS that is equipped with the Core i7 7700HQ CPU, GeForce GTX 1070 video card that is faster than GTX 1070 in the desktops, and 12 gigabyte of DDR4 2400 megahertz. So I'm going to start, guys, with 12K resolution, and slowly we're going to go 10K, 8K, 4K, 5K, 1080p in the end. Okay, just to underline our tests today. So we're going to run 11,520 pixels by 6,480 pixels, which is 12K resolution, 16 divided by 9 aspect ratio. Unfortunately, on a GTX 1070 video card equipped with the 8 gigabyte of GDDR5, this is the maximum possible that we can run. Ultra high resolution, so we gotta make sure everything at low, because otherwise visuals at low, otherwise we're going to overload our VRAM. Okay, we also overloading our VRAM at 10K resolution if the visuals is not at low. Keep that in mind. At high, everything maxed out except the anti-aliasing at 10K resolution is 1 FPS, and crazy 2 gigabyte of VRAM overload that is storing the data by the driver from the VRAM into the system RAM, those extra 2 gigabytes, and it's creating 1 FPS average and about 2000 milliseconds latency delay. It's not even testable, not even playable. Okay, so lack of VRAM to run at 12K resolution, everything maxed out, or 16K resolution, even not possible to run it at low, because 12K resolution at low and 16K resolution at low, there is a big difference, like 70 megapixels versus 134 megapixels, big difference, right guys? So this is how we're going to do the first test. I'm going to run my benchmark demo, and I'm going to type in the console, I'm going to type play demo space benchmark. This is the command to play the demo files. Guys, I'm going to attach this, my own benchmark demo file, in the video description for you to download. If you have Left 4 Dead 2 game, you can put this demo file into the demo folder, and play it, and pretty much play the same scenarios, and you can test your own PCs and see how faster your PCs or how slower your PCs today versus my laptop with the GTX 1070 and the Core i7 7th generation 7700 HQ CPU with the locked multipliers, running completely stock. GPU not overclocked, VRAM is not overclocked, CPU is not overclocked, and I'm going to for sure to compare it with the Titan RTX on the Core i9-9900K, as well as maybe 2 Titan RTX and SLI, if this game will support the SLI, as well as RTX 2080 Ti video cards in the future, over the iPlay4k.com YouTube channel. Check it out, 38 FPS average. Wow, latency delay is below 25 milliseconds average, kinda. I would say below 30 milliseconds average, which is still playable for this particular Left 4 Dead 2. This is the second game, guys. It was Left 4 Dead 1, which was using the pretty much the same source game engine as this one using, but I believe this one is using a little bit updated source engine. And if it's not updated source engines comparing to Half-Life 2 Episode 2, then this game for sure using the higher polygon counts per 3D meshes, per 3D models, as you can see. And this is why I cannot run this game at 16K resolution on GTX 1070 laptop, when I can do the same thing on GTX 1070 laptop in Half-Life 2. I can do maximum visuals except the anti-aliasing at 16K resolution, keep that in mind. But this game has more details in terms of the polygon counts, as you can see, and a little bit of more details in terms of the effects. 38 40 FPS average, I would say. Keep in mind that this gameplay today, guys, I'm recording with a shadow play, so please add 3 FPS to the FPS counter because it's recording on the same computer with NVIDIA Shadow Play software, and it takes 3 FPS as I saw it. So 42 FPS without the recording, 42 FPS, but with the recording 38-40 FPS average, the latency delay below 30 milliseconds, great. Check your eyes, guys, at the CPU usage, which is 812% right now, amazing. And this is the quad-core 8 threads, so pretty much 8 visual cores in Windows and only 16% maximum CPU usage. The GPU usage, look at this, 98%, wow, 97%, I call it very good GPU utilization, especially when it's 99%, I call it excellent GPU utilization, but right now it's very good GPU utilization. We want to keep our GPU utilization, as you can see at the left top, right now 98, 97%, we want to keep that as high as possible, and CPU utilization we want to keep below 90%. The FPS we want to keep as high as possible for those beginners who doesn't understand the PC hardware yet, and the latency delay we want to keep as low as possible, because latency delay, it's pretty much in milliseconds delay before each frame is rendered, delay between the GPU, and this delay caused by the GPU, VRAM, system RAM, if system RAM is used, CPU, and the software, which is the 3D render API. Okay. So we got it, Houston, we got it. Okay, so this was the 12K resolution low. Let's go ahead and switch to 10K resolution low, because 10K resolution is impossible to run on high. So 10K resolution, 10,880 pixels by 5760 pixels. Okay. I already tested this game, I didn't have any issues, guys. Keep in mind, I cannot wait to test this game with the Titan RTX. It's going to be amazing, and with 2 Titan RTXs in SLI, if it will be supported. So let me real quick go ahead and verify that. 10K resolution, everything at low. Let's go ahead and play the demo. Benchmark is again. Wow, guys. And then I'm going to switch to 8K resolution. I want to show you the 8K resolution, everything maxed out, at 8K resolution at low, 8K resolution, everything maxed out without the anti-aliasing, 8K resolution with 4 times MSA, because it's struggling with 8 times MSA, but I'm going to show you how it's going to struggle with 8 times MSA. And then I'm going to switch to 5K resolution with 8 times MSA, everything maxed out, 4K resolution with 8 times MSA, 4K resolution without the MSA, and then 1080p, everything maxed out with 8 times MSA. So pretty much we would like to pretty much underline and test all kind of resolutions, so we during this gameplay, during this video, we're gonna get all kind of information and all kind of data for all kind of thinking. If you're going to think from any kind of angles, you're still going to receive a value and going to use this data, guys. Let's say if you're purchasing a PC, or if you're a PC hardware enthusiast or PC overclocker, it's nice to know what's up, it's nice to know where is the future. Look at this, it's running beautifully, guys. Average 45 FPS, and the latency delay is below 25 milliseconds, same as it was the 12K resolution, below 25 milliseconds. In this particular game, latency delay below 30 milliseconds, guys, is still comfortable gameplay. But as you already know, I already gave you the formula. Totally comfortable gameplay, no matter what kind of game you're playing, you want to keep below 10 milliseconds. But for the old school games that was released before 2015, 30 milliseconds is still good to go, guys, in latency delay, if it's below 30 milliseconds. Guys, I'm coming today in real time. I will try to make this video uneditable, and I will upload it on YouTube the way it is. I'm not gonna edit this video. Don't forget to smash that like button, guys. A lot of time, money, energy was invested just to show you the future, to show you a lot of experience, a lot of information. Subscribe, click the bell, share it with the friends, guys. Support me with the positive comments, motivate me to record more videos. 45 FPS average, as you can see, and below 25 milliseconds latency delay. Okay, let's go ahead and quit that for now. And what I'm gonna do now, we got enough of information. I'm going to go ahead and switch to 8K resolution, which is 7680 by 4320, which is 8K 16 divided by 9 aspect ratio. We're going to try this resolution with everything at low, and then we're going to go ahead and get the everything maxed out without the anti-aliasing, and everything maxed out with 4 times MSAA, and everything maxed out with 8 times MSAA. I will show you what is the diagnosis when the VRAM is overloaded, so you will know for the future. So let's go ahead and real quick verify everything as low as you can see. Let's go ahead and run our benchmark. As again, I'm using the console and I'm using the command play demo space benchmark, and the benchmark is the name of my demo file that I'm going to include in the video description with instructions how to test it yourself if you do have Left 4 Dead 2 game. Look at this, milliseconds delay, guys. You want to keep your eye on CPU usage as well, because the lower resolution will be, the higher CPU usage will be, and the lower GPU usage will be. So this is what we don't want to have. We want to have as high as possible our GPU usage, so we're going to utilize all the CUDA cores in our GTX 1070 Pascal GPU architecture today, and we're not going to just waste some CUDA cores for nothing per each second. Hopefully this makes sense. Average FPS 85 FPS, latency delay below 15 milliseconds, so right now it's running very comfortable, guys, especially at 8K resolution. Imagine you can play this on 8K resolution screen, and I do understand there is some screen 30 Hz, there is some screen, today I'm playing this test today on 8K resolution 30 Hz native, and it will be 60 Hz, it will be 120 Hz 8K resolutions, but the FPS will be the same. Hertz on the screen doesn't reflect the rendered in real-time FPS before it's sending that signal to the screen. Keep that in mind. When people doesn't understand that on YouTube, when they're reviewing the monitors and they're recording 120 Hz gameplay or 144 Hz gameplay, it's still the same as 60 Hz gameplay, because you're recording at 60 FPS. Keep that in mind. Or 30 FPS. So some people doesn't understand that, but the Hertz doesn't reflect your FPS. Keep that in mind, especially when the FPS is unlocked. And in our case, I'm not using vertical sync, the FPS is unlocked, so the maximum possible FPS for us as demonstration, so we can see where we at. Okay, 85 FPS average, the latency delay below 15 milliseconds. The CPU usage was like 15% and below, and GPU usage was still great, 95%. Excellent. The VRAM usage was like below 5,000 megabytes, guys, and the system RAM usage was 6,103 megabytes. All right, good to go. Let's go ahead and quit that. Let's go ahead and do now 8K resolution, everything maxed out. So 8K resolution, I'm going to enable and make everything maximum possible visuals, but without the anti-aliasing first. We just want to see how it's going to perform without the anti-aliasing, and then 4 times MSA and as anti-aliasing, and then 8 times MSA as anti-aliasing, but it's not going to take for a long time. It's probably going to crash, not crash, but it's going to overload our VRAM, and it's not going to be even testable or benchable. I'm not even going to talk about the gameable. So here we go. Let's verify that. Okay, good to go. Starting the benchmark. Right now the GPU utilization should be higher than we had at 8K resolution with low, and the CPU usage should be less than we had at 8K resolution with low, because right now we must heavily utilize our GPU. Still great FPS, guys. Look at this, 60 FPS average. Wow. Latency delay is still below 20 milliseconds, so it's still comfortable for this particular game. The CPU usage, wow, I just saw 18%. 20% even. Wow. So we increased a little bit on the CPU usage, just a little bit, but few percentage. The system RAM is 6,560 megabytes, and the VRAM usage is a little bit above 5,000 megabytes, as you can see, but still below 6 gigabytes of VRAM. So we're utilizing 5,165 megabytes on our VRAM right now. Still pretty healthy in terms of the VRAM utilization. Guys, my formula for the VRAM utilization, you want to keep 15% free of your VRAM, 15% free of your VRAM from the capacity of total of your VRAM capabilities on your video card. Keep that in mind. This way, you're not going to store any data into the system RAM, and you're not going to reflect your FPS. You're not going to lower your FPS, and you're not going to ruin your experience with the high latency delay in terms of milliseconds. Keep that in mind, because every time you're storing some data in the system RAM, your milliseconds latency delay is increasing, and you want to have your milliseconds latency delay as low as possible and FPS as high as possible in PC gaming, console gaming, mobile gaming, anywhere. So pretty much latency delay, guys, is each frame render time, and pretty much this latency delay caused by the GPU, VRAM, system RAM if it's storing some data into the system RAM, and CPU speed, of course, and the software, which is the 3D real-time rendering API. If it's going to be slow rendering API, it's going to be slower, it's going to be higher latency delay. If the rendering API, like, let's say like a Vulkan or something like that, is going to be lower latency delay, etc. Okay, guys? As you can see, we are already throttling a little bit on our CPU, so usually it's staying 3600 megahertz on this i7 7700 HQ CPU, but right now it's showing 3500 megahertz, so we're throttling a little bit. The CPU is trying to lower the temperature from 83 Celsius, a little bit lower. So 83 Celsius for this 7th generation Core i7 is kind of starting thermal throttling point, and it's lowering by 100 megahertz. So we're probably losing 1 or 2 FPS right now. Okay? So you saw everything. Let me go ahead and quit that now, and we're going to go ahead and utilize the 4x MSA with 8K resolution. So anti-aliasing 4x MSA is going to be runnable. I already tested, I know it for sure, but 8x MSA we're going to have an issues. So 4x MSA, let me real quick go ahead and double check it, make sure everything is right. As again, guys, I'm not going to edit this video, I'm just going to upload it the way it is. Let's go ahead and execute the benchmark. Here we go. And I'm coming, guys, in real time. English is not my first language, but I know a lot of information and a lot of experience about the PC hardware. I'm a PC hardware enthusiast, PC overclocker, PC gamer since 1998. Keep that in mind. Plus, I'm a software developer, hardware engineer, graphic designer, and 3D artist. So I have a lot of information with you guys to share. All the valuable information. There is no copycat information involved here. There is no trending information here just to pretty much waste your time. Everything that you're watching over the iPlay4k.com YouTube channel pretty much is unique and without any marketing BS. Based on a true story, guys. Okay, still great, guys. Above 50 FPS average, as you can see. I would say 55 FPS average. The latency delay below 20 milliseconds, which is still great. So very comfortable gameplay. And the VRAM usage is increased right now, as you can see, almost to 7,000 megabytes or 7 gigabytes. So we're using VRAM is 6,996 megabytes, and we increased on our GPU utilization at 8K resolution right now, 95-97%. Our CPU utilization decreased, as you can see, which is great. 15% on the CPU utilization and below. This is how we would like to have it. Our system RAM is 6,600 megabytes, as you can see. And right now VRAM is grown to 7,000 megabytes. So that's why when I'm going to, let me real quick and quit it. So we got all kind of picture that we need to have. That's why, guys, right now when I will put 8 times MSA, everything will be, the VRAM will be overloaded. But let me real quick go ahead and show you what is the diagnosis when the VRAM is overloaded, so you will know how the VRAM overload looks like. Pretty much when your FPS 0, 1, 2 FPS and your latency delay is above 200 milliseconds, it means that you're overloading your VRAM. And this is the case right now, 1 FPS as you can see at the left top, and the latency delay is above 3000 milliseconds. Wow. Right now about 1000 milliseconds. So this is the VRAM overload, guys. That means that a lot of data stored into the system RAM by the NVIDIA driver, and it's not fast enough, and the GPU is struggling to render the things in real time. So I'm going to go ahead and right now switch to 5K resolution, and with 8 times MSAA, everything maxed out. This is how we're going to play it real quick. And then the 4K resolution and 1080p, and we're going to wrap it up. And in the end of this video, guys, I'm going to show you the PC hardware, and we're going to talk a little bit about the PC hardware in this laptop, which is the Asus GL702VS. Such a beautiful gaming laptop that was available in the end of 2016, and I purchased it in the end of 2016. It's one of my personal laptops, and the reason why I kept it, because it's showing the performance of the Titan X Maxwell GPU architecture GTX 980 Ti video card and RTX 2060. Titan X Maxwell GPU architecture will be much better at 12K resolution and 10K resolution. Probably will be able to run it at medium at least, because it has 12 gigabytes of VRAM versus 8 gigabytes of VRAM that I have in our GTX 1070 laptop today. Alright, so what's going on here? Come on, switch it, please. Here we go. And what's going to happen? I'm just going to, so this is the VRAM overload, guys, and pretty much the 3D surface didn't crash yet. We didn't lose our 3D device, but it is a signal that it's game over, because it's storing the data into the system RAM, and it's game over. And you can see the system RAM right now above 7500 megabytes. So my theory is working, and our system and our VRAM was 7980 megabytes, but it is a lie, because it is what it is right now, plus it's additionally probably 2 gigabytes over, and but it's stored into the system RAM. All right, guys, 5K resolution, 5120 pixels by 2880 pixels, 16 divided by 9 aspect ratio. Everything maxed out, 8 times MSA. Let's go ahead and have a look, shall we? Let me go ahead and execute the benchmark. I think that Titan RTX, guys, is 3 times faster than GTX 1070 Pascal GPU architecture. Can you believe it? The Titan RTX Turing GPU architecture, the next generation video card, top dog, 3 times faster than middle grade of the previous generation. And the same scenario will be applying for the RTX 2080 Ti. It will be 3 times faster. However, Titan RTX can give us 16K resolution or above 8K resolution in newer games easy, when RTX 2080 Ti will be struggling, because RTX 2080 Ti Turing GPU architecture video card has only 11 gigabytes of VRAM. And guys, when we're talking 8K resolution and above, you want to have at least 16 gigabytes of VRAM, and I hope that RTX 2080 Ti Super will feature 16 gigabytes of VRAM. And if this will be the case, means that we'll have a new king in the town. You don't need to buy the RTX Titan RTX with 24 gigabytes, because 16 gigabytes of VRAM will be good enough for 16K resolution in any of the classic or old games, and will be good enough above 8K resolution in the games that are going to be released in 2020. So pretty much to have performance of the two Titan RTXs, guys, we need two more NVIDIA GPU architectures. So single GPU will give us, single video card will give us the same performance as two Titan RTXs. Two more generations. The next generation after the Titan RTXs and the next one after that. If you don't like to run two Titan RTXs on SLI when you're playing 16K resolution, or when you're playing 10 or 12K resolution in the games that was released in 2020, keep that in mind. All this information will be available, guys. Titan RTX videos are coming. I didn't forget about you. Stay tuned. As you see, nobody else is capable to show you this craziness, this ultra high HD resolution. Only I play 4K, aka I play 16K, and I do it with so much information as possible as can be delivered to you guys. Alright, so guys, as again, 14% on the GPU usage, but still below 20, on the CPU usage below 20% utilization or usage on the CPU usage at 5K with the 8x MSA, everything maxed out. Our GPU usage, as you can see, went below 95%. Our GPU usage below 95%. So because 5K resolution, the lower resolution, the less GPU usage and the higher CPU usage. This is the formula by I play 4K, aka I play 16K. Before this, copycats will figure this out and they will copy each other. Those copycats like 2 cents, whatever, Jay-Z, and he took 50 Cent and Jay-Z Nick, and this is why he popular. And Linus copied me, guys, 16K resolution 6 months after my video in May of 2016 on 4 Titan X Maxwells when I was running Half-Life 2 in 16K resolution. Why do you think Linus was running Half-Life 2 in 16K resolution? Because he watched my video, he tried my games, guys. And I was the first on the YouTube with 16K resolution videos. As you saw, guys, the VRAM utilization was below 5,000 megabytes or below 5 gigabytes. The usage on the GPU was below 95%. On the CPU was below 20%. The system RAM usage was below 6,000 megabytes. Okay, now what we're gonna do, we're gonna switch to 4K resolution real quick. It's a very long video, guys, but we need this because I'm providing you a lot of information and pretty much for everybody taste. You know, if you don't like to 16K, you can see how this laptop performs 3K or 4K or any other laptops, or 5K or any other laptops that is equipped with GTX 1070. They will be equipped, guys, with the i7 7th generation 7700 HQ CPUs, like 70% of them, and this is pretty much plus minus 1-2 FPS on any laptop performance that you're watching during this video today. So 4K resolution, everything maxed out, okay, and everything maxed out. And let me real quick lower our overlay so you can at least see at 1080p as well. It's going to look nice and beautiful, because I'm going to show you 1080p for those naysayers, just to show you, to underline my theories about CPU and GPU load at the resolutions. So everything maxed out. Let's go ahead and execute the benchmark. Look at this, latency delay below 10 milliseconds, amazingly well. The GPU utilization above 20%, the CPU utilization above 20%. This is not the 5K, this is 4K. And the GPU utilization still 96% because we're using 4K with everything maxed out, 8x MSA. So we can still keeping that GPU utilization high because the anti-aliasing, guys, 8 times. So when you're having high-end video cards, you want to crank up your settings all the way up, otherwise you're going to raise the CUDA port in your devices for nothing every second. Keep that in mind. You want to stress as much as possible on the GPU, those CUDA cores, guys. So you want to have the GPU usage as high as possible in terms of the percentage. So 6,000 megabytes on the system RAM usage, 3,700 megabytes on our VRAM usage, so below 4,000 megabytes or below 4 gigabytes on the VRAM usage. So pretty much any video card with 4 GB of VRAM, you will be good to go. 4K resolution in Left 4 Dead 2. At 4K resolution, everything maxed out with the 8 times MSA. Of course, you need to have a nice GPU to be able to handle that render in real time, those frames per second in real time. But Pascal GPU architectures such as GTX 1070 and newer GPU architectures and newer video cards and faster GPUs will produce you even higher FPS. Keep that in mind.
Reloading.
Wow, below 10 milliseconds. I would say below 7 milliseconds average latency delay. This is amazing experience over here going on, guys. Silky smooth for any type of personalities.
Please. I'm reloading.
97, still very high GPU usage, which is amazing. GPU usage is 97%, but CPU usage above 20%, almost 25%. So right now we're fully utilizing 2 cores, pretty much at 100%. If I would have 2-core CPU. Guys, for games, you want to shut down your hyper threading technology as much as you can, and you can only try to use only the physical cores instead of the logical cores, because the physical cores is faster by, I would say, by 1.5 times than the logical core. That's why when I played i9 9900K, I shut down my 2 cores, made it 6 cores, and I shut down my hyper threading technology to keep it 6 cores, 6 threads, the less cores possible, without any hyper threading, so only the physical cores. So this way, I was receiving the highest FPS ever possible, because the less core, the less latency delay. Keep that in mind. Okay, so let's go ahead on one more test. I'm going to just go and disable the anti-aliasing completely at 4K. Let's go ahead and have a look how it will perform at this type of scenario, and then so 4K without the anti-aliasing, and then 1080p, and that's it. We're going to wrap it up. And as again, in the end of this video, I'm going to show you what kind of PC settings, what kind of PC hardware I was using in this laptop, a little bit briefly about the hardware in this laptop. Okay, wow, 250 FPS average, the latency delay below 5 milliseconds. Amazing experience over here going on, guys.
What are we waiting for? Let's go.
If you have a 65-inch, if you have 75-inch TV and 4K TV, then you need to enable the anti-aliasing. If your screen below 75-inch, you don't need no anti-aliasing, even at 4K resolution. But 8K resolution, you don't need no anti-aliasing, even with the 85-inch TV. You're not gonna see it, guys. Keep that in mind. Wow, great. The CPU utilization, look at that, 30%. Here we go. Remove 4K, remove the anti-aliasing, and the CPU utilization is kicking now higher than it's supposed to, and the GPU utilization will just went below 97% as we had at 4K with 8 times MSA, as you can see, guys. So my methods and my theories are working in terms of CPU and GPU usage at all kind of different UHD resolutions. Exactly as I told you, this formula is working, as you can see. And our CPU temperature right now 90 Celsius, so it's going to probably running a lot at 3500 megahertz because it's kind of thermal throttling itself, but it's going to start heavily thermal throttle itself at 99 Celsius. But just because I downvolted my CPU, it will never happen. So this is the best way to do it. If you don't want to go inside of your laptop, if you don't feel comfortable, you can downvolt your CPU, guys, and still receive 2-3 Celsius lower in CPU temperature. Alright, guys, we saw everything that we need to see. Very low VRAM usage, below 3000 megabytes. Also, the system RAM usage was below 6000 megabytes. Right now, I'm going to go ahead and go extreme for those naysayers. For the resolution, there's Stone Ages, which is dead, but still 1920 by 1080, just to underline it. And 8 times MSAF course, everything maxed out. 1080p, guys, maxed out completely, because you definitely need to anti-aliasing for 1080p, especially if you have 65-inch 4K TV or above. If you're playing 1080p, you definitely need the anti-aliasing. Okay, now you can see at least the console. Okay, guys, let's go ahead and have a look, shall we? Wow, look at this. 300 FPS average. For sure, below 5 milliseconds latency delay is just running crazy. But GPU utilization, below 50%. We're not utilizing every second, even 50% of our CUDA cores.
Let's go.
Oh my god. Okay, right now we're doing like 54, but still, 40% of the CUDA cores is the waste. So means if you're playing this type of resolution, you better buy yourself a cheaper video card, save the money, because it's still going to be waste. And 1080p resolution is waste, guys. People that saying that 1080p is everything for them, they remind me their fathers, naysayers, that was saying that 1024 by 768 or my YouTube channel back in 2007 is still great for them. 1080p, guys, resolution will die, and the whole PC gaming will die in 2025, guys, and I will record a video when I'm going to explain it to you in details why I think so.
Reloading.
But don't smash that dislike button. I'm just sharing with you the truth, guys, even if it hurts a little bit. And it's better to hear this theory, because I believe my prediction will be correct. 2025, it will be no PC gamers and no console gamers, only the enthusiasts. But most of the gamers will be on the mobile devices, and I predict iOS gaming devices and the streaming services. But still on your phones and tablets. And during that time in 2025, the Apple iOS devices will have a bionic chips that will feature 16 core on CPU, 32 cores as an ARM cores, and 64 cores on the GPU, and it will be over for the PC gaming era for sure. Alright guys, 270 for sure FPS average, 250 to 70 FPS average, below 5 milliseconds. VRAM usage was below 3000 megabytes. System RAM usage was almost 6000 megabytes. The CPU utilization was 40%. The GPU utilization was below 60%. Good to go. Let's go ahead and be done with that. It's over. Let me real quick go ahead and show you what kind of specs I was running today in this laptop, and we will be over, guys. So as again, I will include this demo file in the video description if you would like to test it and compare it with your Left 4 Dead 2 PC hardware. Point single thread performance on this, let me real quick go ahead and show it to you. So this is my CPU, guys. The motherboard GL702VS, but the laptop model is Asus GL702VS. Memory 12 gigabytes. If you're having this laptop, go ahead and upgrade it to 16 gigabyte of DDR4. You can buy 8 gigabyte of G.Skill 2400 megahertz for $29, and it's easy to do. Okay, the best version of the GTX 1070 video card, guys, the best revision, as you can see, with 8 gigabyte of GDDR5 Micron. So single thread performance 360. 360 is only when I'm down volted my CPU. When the CPU is not down volted, it's 330, 320 average. So you will receive a higher performance if you will down volted by a little bit to keep it cooler, even without repasting thermal compound paste. And I'm advising you to repaste it with a liquid metal thermal compound by Thermal Grizzly. So you're going to receive the maximum possible performance minus 10 Celsius from what you saw today on the CPU and GPU, and it will never thermal throttle in these conditions, okay? Because thermal grizzly liquid metal thermal paste is the best, guys. Multi-threaded performance is 1922 score. Keep in mind that my Core i9 9900K under the single-threaded performance showing 630 points average, and under the multi-threaded performance showing way above 3600, but with only 6 cores, 6 threads, when 2 cores and hyper-threading technology is disabled. Keep that in mind. And this is CPU Z 1.87.064 bit, and the test version 17.01.64. Okay, and real quick for those naysayers, let me show you the GPUs. This is the video card computing this type of scenarios with the OpenCL and the Core i7-7700HQ that has the lock multiplier, so it's not overclockable CPU. Kind of same scenarios, but within the natively optimized, heavily optimized x64 machine code. Usually it's slower than that. But you can compare the CPU to GPU computing, kind of in similar scenarios. Then let me real quick go ahead and show you guys everything what I have. For those who's curious to buy this laptop, if you're curious to buy this laptop, I advise you to buy it used like new for $500, maximum $600. Even if the battery is dead, you can use this laptop as your desktop. Keep in mind that during this scenario, RTX 2060 laptop should cost above $600. Otherwise, grab yourself used like new RTX 2060 video card laptop. Okay. This is about the CPU, motherboard, GPU. Okay, here's my GPU. So 8 GB of GDDR5. All the information, guys. 2048 CUDA cores versus 1920 CUDA cores in the GTX 1070 in the desktops, as you can see, and 128 TMU units versus 120 TMU units in the desktops. Okay, and this is not just guys, this software is kind of showing the wrong information. It's not. It's showing the correct information. Let me show you the GPU Z real quick, and I'm going to wrap it up with this video, guys. The GPU Z real quick. It's the same information about this GPU, Pascal GPU architecture, about this GTX 1070 video card. As you can see, same deal as you can see, guys. 2048 CUDA cores, and TMU units will be 128 TMU units, guys. The same story, same deal. Video card was running today, guys, at stock. As you can see, no overclock on the VRAM, no overclock on the GPU, but you can overclock it if you will replace the thermal compound with liquid metal. But you're going to do it on your own risk and expenses. I'm not responsible if you're going to damage anything, and I'm going to create a video when I'm going to do it on this laptop, as well when I'm going to replace the 8 GB of system RAM in this laptop, G.Skill 2400 MHz, as well as when I'm going to replace this mechanical 1 TB Western Digital hard drive into crucial 2 TB SSD. Alright, but mechanical disk or SSD doesn't improve the FPS in the games, it's only improve the loading time. Thank you so much, guys, for watching. Right now I'm putting on screen the cool videos for you to watch. If not, check the video description, and don't forget, smash that like button for support. A lot of time, money, energy was invested. Subscribe, smash that ring bell icon, and positive comments, and I will see you in the next videos. Share it with your friends. Till the next time.